Good day once again, viewers. My name is still Israel Egwai. You are welcome back to class. As we already know, this is Jamb class. Most of the topics we are treating is just well selected. So we are not going to all those 1 hour topic, 1 hour teaching and others. It's just small that will make you to remember almost all the things in that particular topic where these questions are picked from. So kindly listen very well, watch it, relax, and try to understand. It will help you. Now, the first question we are going to consider is explain the effect of pressure on the following reactions. See, 3 reactions are given. Please do well to kindly look at it properly. The effect of pressure. The first one is 1, 2SO2 plus O2 to give you 2SO3. They are on gaseous form. When you are talking about pressure, your mind goes straight to gaseous form, gases. Your mind should go straight to only gases, because gases that can be compressed, you don't consider any other thing. For example, look at this. We discussed this one in our previous video. If you want to know, you can go back and check it. So for pressure to affect it, even if you have change enthalpy change, delta equals minus of, that doesn't concern you. It's only when you are looking for temperature, then this one, the number of moles does not concern you. But when you are dealing with pressure, enthalpy change does not concern you because it's different from temperature. So for pressure, just look at the gaseous molecule. This is a gas, this is a gas, this is a gas, correct? You now say 2 moles, 1 mole, and here 2 moles. Because they say you explain the effect of pressure. So for this, you have total here, left hand side, you have 3 moles. Right hand side, you have 2 moles. You see it? So 2 moles producing 3 moles. Pressure change will favor the side that have the lesser mole. So increase in pressure will favor the forward reaction. Increase in pressure favors the side with the lesser mole, and vice versa. So why decrease in pressure favor the side that have the higher mole? So if you increase the pressure here, it will favor the forward reaction. Increase in pressure favor the forward reaction. More sulfur 6 oxide SO3 will be formed so long as you increase the pressure, because it's the side that have the lesser mole. Look at it, 2 moles right hand side, it's already written. 3 moles left hand side. Why decrease in pressure favor the backward reaction? Remember, any side that is favored is what equilibrium constant will shift to. That is that on pressure. On the first one. So let's have a look at the second one. You look at the CaCO3, CaCO3 solid to give you CaO solid plus CO2 gas. Me looking at it, some of you will just say, how can you have a reversible reaction when you have decomposition? And how can it be reversible? It can be reversible when it's done in a closed system. This one will handle it another day in another video. You see it can always be reversible so long as it's done in a closed system. Once you are heating this, subject it to high heating, limestone, it will decompose to calcium oxide and carbon dioxide. In as much as you don't allow anything to escape, a time will come when carbon dioxide will start reacting with the calcium oxide, and as it's reacting, it will start reforming the product. This is forward reaction, and this is reverse reaction. We start forming it back. When the time comes, when the rate of formation of the product is equal to the rate of formation of the reactant, you have equilibrium has been attained. So that is how that one goes. For this situation, they say you should identify whether increase or decrease in pressure will favor this. It will not work, because remember the rule is this: for pressure to take effect, 1 or more of the reactant molecules and that of the product must be in gaseous form. Here there's no gas, no gaseous form, so pressure will not have any effect in this kind of reaction. Then the last one, 3Fe plus 4H2O to give you Fe3O4 plus 4H2. This is a gas, solid, You can see it. I think that's the last reaction we are going to consider. That's the last reaction we are going to consider for today's video. If you look at it, remember we said for pressure to affect any reaction in equilibrium, the number of moles of reactant molecules, that are gaseous on the left hand side must not be equal to that on the right hand side. First of all, solid have no effect because the concentration is fixed, they are constant, so it doesn't have business with the equilibrium constant. So you see this solid, you remove it. You check again, this solid, you remove it. What is left is 4H2O, so you now consider it 4 moles. Consider this one again, 4 moles. It has become necessary for me to use this video and this equation because of what many of you are asking me in comment section. Is it true that solid will affect it? Is it true that solid will not have effect on equilibrium constant? It will never have effect on equilibrium constant because the concentration of solid is constant. This pressure we normally use. So you have 4 moles here equals to 4 moles here. 4 moles on left hand side is equals to 4 moles on right hand side. And like we said, for pressure to have effect, the number of moles of gaseous molecule on the left hand side must not be equal to the number of moles of gaseous molecule on the right hand side. Since this one is 4 and this one is 4, then pressure will have no effect. Pressure have no effect. No effect of pressure. And when you are calculating the equilibrium constant, what you just do, you cancel this one off. So that reminds me, let's assume we want to write the equilibrium constant equation for this kind of reaction. This one will settle all the issues. We want to write the equilibrium. We have already removed this. We have removed it. The next thing we are going to do is say K. Either you call it KC or KEQ, whichever way is K. Equilibrium constant will now be H2, the concentration of this equilibrium constant expression over H2O. 4. This is the equilibrium constant expression for this. Don't ever include this. No matter where you see it from, it doesn't have effect. Don't ever include solid. Solid are not necessary in this topic, even though they play a role, but they don't have effect on equilibrium constant. And that reminds me again, the only factor that affects equilibrium constant is temperature. Thank you very much, my viewers, for watching. Please kindly subscribe, share, and also like. God bless you all.